We have a quadratic equation, x squared plus 6x minus 7, and we want to simplify it. One way to do so is with completing the square. We can take the middle coefficient 6 and divide it by 2, where on one end we have x plus 6 over 2 squared minus 6 over 2 squared minus 7. If we simplified this, we would see that we would have x plus 3 squared minus 16. Now this is much easier to work with. And if we want to see completing the square in more general form, we have a quadratic equation as x squared plus bx plus c. Now we can take the middle coefficient b divided by 2, and then we do the same thing as we did before, where on one end we have x plus b over 2 squared minus b over 2 squared plus c. Looks pretty familiar, right? But we're not really understanding what's happening behind the scenes. Let's take another angle, the geometric angle. We can represent the first term as the area of a square, where side's x and the area is x squared. We can do the same for the second term, bx, where one side is length b and the other side is x, and the area is bx. Now we can split that rectangle into two, where the area of each smaller rectangle is b over 2x. Now if we reorient those two rectangles, we could see that we have nearly a perfect square, except for a little area missing at the bottom right. What would that area be? Well, it would be b over 2 squared. Pretty neat. Now if we zoom out, we could see that we could represent our original equation as the shaded area in blue, minus the area that we added since it was not there. Well, how could we do that? Well, the area of the full square is x plus b over 2 squared minus the area that we added, plus c. Well, that's exactly what we did earlier. That's not a coincidence. That is completing the square.